Hey everyone, we're going to take a quick look at number 6 in section 3.4. I've pulled it up on the screen for you to see here because it has a graph, and of course it's just multiple choice in each case. So consider the graph. This is the graph of the distance s from the origin as a function of time for some car trip. And it looks like the time is in hours and the distance in kilometers. So at any point in time, at 1 hour after the trip begins, you can see the car is 100 kilometers from the origin or from its starting point. At 2 hours, the car is about 50 kilometers, and so on. So it looks like we've got this position function, and we're going to be asked questions about the velocity. So the important thing to remember about the velocity is that it is the rate of change of the position or distance function with respect to time. So if s is the distance, ds dt or s prime would be the velocity. Okay, now we don't have a formula. We're not asked to come up with a formula for s, but we want to interpret the velocity in terms of the graph. And the velocity, of course, being the derivative of the distance function, s prime, it is the rate of change, of course, of the distance with respect to time. And of course, in calculus, that's the derivative, which is simply the slope of the tangent line. So, just for example, between 1 hour and 1.5 hours, notice the graph is constant. It's basically a horizontal line. Notice at any point on that interval, the tangent line would coincide, right, with the function and would therefore have a slope of 0, meaning from 1 to 1.5 hours, the rate of change of the distance with respect to time, distance from the origin with respect to time, is 0, which literally means your velocity is 0, right? Your rate of change being your velocity. And that makes sense because the whole time from 1 hour to 1.5 hours, where are you at? You're at a fixed 100-kilometer distance. We're assuming here straight line distance traveling away or toward the point of origin here. So the velocity would be 0 on that segment. Well, let's look on the interval from 0 to 0.5. Sorry, 0.5, from 0 to a half, from 0 to 1/2 hour. Well, here's the segment, and notice two things. Number one, certainly it's not horizontal like it is between 1 and 1.5 hours. But at any point, if I look at the tangent line, I hope you can see the tangent line will have a slope that's positive. Okay, which means the derivative is always positive on that interval from 0 to a half. And of course, notice the derivative is the velocity. And one of the choices is the velocity is negative, the middle choice. Well, right away, I can tell that's wrong because I just said the velocity, the rate of change, is positive at every point because the tangent line would be a line with positive slope. But also, as you move from left to right, because the curvature of this graph is such that the tangent line down here at about 0.2 hours has a slope that's less than, say, at 0.3 or 0.4. Notice the slope is getting steeper. So the slope, the rate of change of the position from the origin with respect to time, or the velocity, is therefore increasing, right? So because of that shape, it's increasing. And so the correct choice is the first one. It is not decreasing. Now, let's go from 1.5 to 2. Well, from 1.5 to 2, notice now if I pick any point, the tangent line will be a line that's decreasing going from left to right, okay? And therefore, the derivative of this function would be negative on the interval from 1.5 to 2. But again, since the derivative is indeed the velocity, then the velocity must be negative. So it's going to be this first option here. Now, what about the other two, increasing or decreasing? Well, it turns out from 1.5 to about halfway, about 1.75, the velocity is doing what? Well, it's getting more negative. So remember we said from 1 to 1.5, the velocity was 0. So right at 1.5, the velocity is 0, but all of a sudden it becomes negative, right? So maybe it becomes a -0.5, -1, -2, till about 1.75. So we're getting more negative. If you get more negative, you're actually decreasing, right? Getting more negative, you're decreasing. But then from 1.75 to 2, then the slope, notice, is going back to 0. By the time you get to 2 hours, notice the tangent line would be horizontal right at that bottom point there. And therefore, the velocity would be 0 there. So from 1.75 to 2, you're going to have the velocity actually increasing. So you can't say it's increasing on the entire interval or decreasing on the entire interval. It's increasing and then decreasing. So the only choice is that the velocity is negative. The last one is from 2.5 to 5, 2.5 to 3 hours rather. From 2.5 to 3 hours, again, notice our velocity again is going to be positive at any point. If I pick any point on the graph, the tangent line would have a positive slope. But unlike the first interval we looked at from 0 to a half hour, this time notice what's happening. The slope is some positive number, but as I move closer and closer to 3, by the time I get to 3, what's the velocity? It looks like it's very close to 0, right? The tangent line looks very close to being horizontal right at 3 hours. So we're going from positive number all the way down to 0. Therefore, this derivative is decreasing, and hence the velocity is decreasing. And so that's my final answer. Let's see if I got it correct. Hey, I solved it in one attempt. All right. So I hope this is helpful. If you have questions, as always, please let me know.